In this video, we'll be investigating the nature of inverse functions. Now, when we try to get an inverse function, all we have to do is swap the y and x coordinates with each other. So it's pretty simple. So to show you an example of this, if we have the function y equals x squared, to get the inverse function, we have to swap the y and x values. So we then get the equation x equals y squared. So this is the inverse function. Now it also turns out that all the points for the x and y coordinates have to be exchanged as well. So let's say we had a pair of coordinates on the original function, so let's say x was 3. Then the y value of that would have to be 9 because 3 squared is 9. Then in the inverse function, these two would just be swapped around. So the x value would be 9 and the y value would be 3. So you can just see that the x and y values have just swapped over for the inverse function. Now if we were to take a look at all of this graphically, we'd see that the inverse function is just a reflection of the original function. So if we just draw the line y equals x, just like this over here, which just goes through the origin of the graph at a 45-degree angle, and we draw the original and inverse functions, we'll see that the inverse function is a reflection of the original function across the line y equals x. Now I'm just going to draw the original function that we were looking at before, that being y equals x squared. Now when I draw the inverse function, we'll see that the inverse function is just a reflection of the original function across this line. Now, depending on how much of a visual person you are, it can be pretty difficult to see by looking at this graph straight on, to see that the inverse is actually a reflection of the original function across this line. It's certainly something that I struggled with when I was first learning about inverse functions. But I find that if you tilt your head to the right, so that the y equals x line looks like a straight up and down line, it's much easier to see the reflection. You can now see how the line y equals x really acts like a mirror. Now if we move the original graph, the inverse graph moves accordingly. Now when you're drawing inverse functions, especially when you first start off, I'd suggest that you draw the y equals x line as well as working out some points algebraically, by swapping the y and x values, just so you can double check visually that the graph you're drawing is an actual reflection. Now I'm just going to make these graphs different colours so we're not so confused. Let's put a point on the original function. So you can see here that we've got the point A, which is on the original function, the parabola. Now if we reflect this point on the inverse function down here, you'll see that the coordinates have actually swapped around, just like this. So you can see here how it's 1.97, that's the x value, then the y value is 6.01. Then in the inverse function, the x value is 6.01 and the y value is 1.97. So they've just swapped around. And if we move this point on the original function, it also moves on the inverse function, and the coordinates still swap because the point on the inverse will always move accordingly with the point on the original function. Now let's take a look at the equations of these graphs. So you can see for the original graph that the equation is y equals x squared plus 0.84x, take away 0.49. By the way, don't worry, you won't get an equation that's this difficult in a test or an exam, but it's just for this example. And you'll see in the inverse function, the equation is negative y squared plus x, take away 0.84y equals 0.49. So you can see, if you can just look at both of these equations, you can see that the x and y coordinates have actually swapped around again. So you can see that wherever there was an x in the original has now been replaced by a y in the inverse, and vice versa. So what we've done is establish that when we're looking for an inverse function, we have to swap the x and y coordinates of the original function.